Today we're going to be looking at rationalizing denominators. Our first example is 4 divided by the square root of 6. In order to rationalize the denominator of the square root of 6, we take it times itself, which simply removes the radical, and we're left with 6 in the denominator. But what we do to the bottom, we also have to do to the numerator, so we get 4 times the square root of 6 on the numerator. We know 4 and 6 both have a common factor of 2, so we reduce that 4/6 to 2/3, and we're left with 2 radical 6 over 3. Our next problem is 5 times the square root of 25, which we know is 5, and the square root of 16m in the denominator. The square root of 16 is 4, so we bring that outside the radical, and we're left with m inside the radical. So again, we take it times itself, and we get 4m in the denominator. But what we do here, we also have to do to the numerator, and we get 25 radical m over 4m for our answer. Now we're given the cube root of 8/3, and we rewrite that as the cube root of 8 over the cube root of 3. We know the cube root of 8 is 2 because 2 times 2 times 2 is 8. We still have it over the cube root of 3. We now take that times the cube root of 3 squared because 3 squared is 9 and 9 times 3 is 27. The cube root of 27 is 3 because 3 times 3 times 3 is 27. We have to do the same thing to the numerator, so we have 2 times the cube root of 3 squared, which is simply 9, divided by 3. Our next problem is to rationalize the denominator of the square root of 3m over 5n. We can write that as the square root of 3m over the square root of 5n. Once again, we take it times itself, and the radical goes away, and we're left with 5n in the denominator. And we have to also do that to the numerator, and we're left with 3 times 5, which is 15, and m times n. So we're left with the square root of 15mn divided by 5n. Our next problem is the cube root of 3 divided by the cube root of 8t to the 5th. So we're going to take the denominator times the cube root of t, and we have to do that to the numerator as well. So on the numerator, we get the cube root of st. In the denominator, we get 2t times cube root of t cubed. Well, the cube root of t cubed is t. So now we have 2t times t for 2t squared. So our final answer is simply the cube root of st divided by 2t squared. Continuing to rationalize the denominators, we have 7 divided by 5 radical 3 plus 1. When you see something like this, you multiply by what we call the conjugate, which is the same stuff, only with a minus sign. The reason why we do that, when we FOIL this, we do not get a middle term. It goes away. And we're left with simply 5 times 3, which is 75, minus 1 for the denominator. Now we have 7 times the quantity 5, square root of 3 minus 1, as a numerator. Continuing to simplify, we do our 75 minus 1 to find out that's 74. Going ahead and distribute that 7 to the 5, we get 35 radical 3, and the 7 to the negative 1, we get negative 7. So our final answer is 35 radical 3 minus 7 divided by 74. Continuing to rationalize the denominators, here's another conjugate. We have in the denominator the radical 7 minus the radical 11, so we take it times the radical 7 plus the radical 11. And what we do to the denominator, we also have to do to the numerator. Continuing to simplify, we have the radical 7 squared, which is just 7, and the radical 11 squared, which is just 11. So we have 7 minus 11 in our denominator. When we take radical 5 times radical 7, we get radical 35. And radical 5 times radical 11 is radical 55. Then we have the radical 7 times 1, which is just the radical 7. And the radical 11 times 1 is just the radical 11 as well. Continuing to simplify, we can take that 7 minus 11 and find that it's a negative 4. None of the radicals up here simplify anymore, so we're left with the radical 35 plus the radical 55 plus the radical 7 plus the radical 11, all of that divided by a negative 4.